Hey class, we're looking at solving systems by adding or subtracting, and this is called the elimination method. So we solve the system by adding or subtracting the system to eliminate one variable, and then we can solve for the other and plug it back in and get the second. So let me show you some examples. I think elimination will probably make the most sense to you. So what we do here is we have two equations. Okay, now notice that our x values, this is in standard form. Both equations are in standard form, and elimination works best when both equations are in the same form. So standard form or slope-intercept form. I wouldn't recommend point-slope form, but it works best with when these two are in standard form or slope-intercept form. You can eliminate pretty easily. Notice here how we have 2x and then we have a negative 2x. These two are opposites of one another. So if we were to add like we add in columns, we could eliminate, hence the name, we could eliminate the x values by adding everything up in columns. So we just make it one big equation that has eliminated the x variable. So the 2x minus 2x becomes 0, and we have 3y plus 9y equals 12y, and then we have 11 plus 1, which equals 12. So we're left with, basically, when we combine these two equations into one problem, we get 12y equals 12. Well, that leaves us with y equals, you guessed it, 1. So then, now we know that y is 1, we can plug that back into either equation, or again, we could try to quickly plug it into both to make sure we get the correct answer for our x value. And if I plug in 1 here, that gives me 3, so I have 2x plus 3 equals 11. Subtracting 3, that's going to give me 2x equals 8. And then, therefore, that leaves me with x equals 4. And I can quickly check it with the second one. If x is 4, that leaves me with a negative 8 plus 9, because y is 1. Negative 8 plus 9, guess what that gives me? Positive 1. So there's my quick check for that. So my answer to this system is 4, 1. 4, 1. So what do you think of elimination so far? It's pretty easy, especially when they're set up this way, and one of the variables is basically the opposite of the other in the other equation. If we look at our second example here, here's a great way where elimination will help us, but it's not as easy as the first example here. So we can see here that we are selling popcorn and mixed nuts for $5 and $8 respectively, and we know that the band sold 240 cans. They made $1,614 is what they collected. So you want to find how many cans of each they sold. Well, let's write our two equations first. Okay, that's the first thing we need to do. And so we know the number of cans is 240. So that means the number of popcorn cans plus the number of mixed nut cans has to equal 240. You want to be sure to identify your variables. Here in this situation, I'm going to use P for popcorn and M for mixed nuts. So then my second equation is, I'm going to relate the total number of cans and the amount of sales here. So my first equation here was P plus N equals 240. My second equation is the money value, because $5 times the number of popcorn plus $8 times the nuts is going to give me 1614, which is what we were told in the problem. So now, if you look over here, notice, first of all, in our set of equations, neither has the exact opposite that we could eliminate right away. However, if we were to take and multiply this top equation by negative 5, notice what that gives us. Well, it gives us negative 5p minus 5n equals negative 1200. So now we have our p's here that are exact opposites. We have 5p and negative 5p. So we can now eliminate. Now, why did I pick p's? Well, because I like to multiply by 5s. You could potentially multiply this top equation by negative 8 if you really wanted to, and it's going to give you the same answer. You're not going to be wrong. It's just most of us, it's easier to multiply by 5s than it is 8s. Obviously, if you have your calculator, it's not going to make a difference too much, but I know I'm more accurate with my 5s tables, so I less likely to make mistakes. Pick those easy numbers. Don't make it hard on yourself and multiply by 37, when you could multiply by 10 instead. So things like that. Just be thinking of that as you're doing these problems. Now we can solve the system by elimination. We're going to add the two equations together. Notice how I set everything up into columns. And I'm left with 3n equals 414. Well, that means n is going to be 138. So if we sold 138 cans of nuts, that leaves us with 102 cans of popcorn. Okay? Now, a few things to think about here. I multiplied this by my top equation by a -5. You could potentially just multiply it by 5 and then subtract. And I think there's an example in your book that shows you the subtraction if you want to look at that. I think it's easier to make it one positive and one negative, and make sure you have that written in the equation. What the book will show is that you have this little minus sign out here, and you're taking the top number minus the bottom number, and you have to remember to subtract all of the time, and oftentimes students will lose that sign. So you want to kind of be careful, watch your signs completely. It's always a good idea too to just plug in both numbers into one of the equations and make sure it works for both. It's a quick check, and more than likely, your errors are going to be made with signs, not any big things. So just take your time with it a little bit and make sure you're picking, obviously, the best method. Now, think about it. If you had an equation, then both of them were set up in standard form, why would you try to graph it? It would require you so much more work to rearrange both equations into slope-intercept form and then graph it and find the intersection, as it would be to just solve it using elimination. So those kinds of things will save you time. Using the best method for each system will save you a lot of time, and it'll also save you some grief and havoc. If you've tried the quick check, go ahead and try those. Again, I know we do some of these in class, but I'd like you to try them tonight. Warning, I'm going to give you the answers now, so pause if you need some time to do them. The answer to this quick check here is going to be, oops, there's my system. It's very poorly written, but I get P to be 85, and then E, which is erasers, to be 135 for this situation. So here's a situation where we had to solve the system, and then I multiplied my second equation by -2 to solve. Could I multiply by 5? Sure. Am I better at my 2's than my 5's? Probably. So again, it's a personal preference here a little bit, but just make sure you're accurate and double check your work. Let's move on to the third and final example here. Our third example, giving it away a little bit, is notice we have a system of equations, and neither of them have the same numbers for their x's or the y's, so we're not going to eliminate right away, right? But we have to think about, and this is where knowing your prime factors and your least common denominators and least common multiples and things really come into play. Because what I want to do is I want to eliminate a variable still. And instead of just multiplying one equation, I'm going to multiply both equations by different numbers so that I can eliminate one variable. So I have to ask myself, do I want to eliminate the x's or the y's? In this case, I think I'm going to eliminate the x's. No preference against the x's. It's just, that was what came to mind first. You could do this problem eliminating the y's, and again, you'd get the same answer. So think about it. If I have 3x here, I need to make these two x's the same value. Well, if I multiply my top number by 5 and my bottom by 3, now they're going to be the same number, right? So now I'm going to have 15 on both the top and the bottom. So then I multiply my second one by a -3. That's going to change the signs so that I can eliminate. The result is, if you look here, I get, if I multiply my top equation by 5, that means I multiply everything by 5, not just that first term, everything in the equation in order to keep it all balanced. So I'm left with 15x plus 25y equals 50. We can multiply by 5s pretty quickly, can't we? Second equation, I'm going to multiply by -3. Okay, and I do that so that I have opposite x's that I can then eliminate. So I get negative 15x plus, or you could even just say minus 21y equals negative 30. So now all of my signs are lined up, so I don't have to worry about the subtraction thing. I can just add my columns, and I've eliminated the x variable. And I can see here my y is 5, and then plugging that y back into either equation. Remember, y is 5, don't plug it into the x. I can then solve for my x, and I can check with the second equation, and I get x equals negative 5. Great job. Real quick, I'm going to show you the answers to the quick check below so that we can come into class prepared to do some problems from the book. Okay, warning, if you're not ready, pause it. We can see here in quick check 2, our x's are already opposite signs, so it makes it really easy for us to eliminate. We end up getting y is 3 and x is 2. Now in our second quick check example here, 2b, we have to multiply the top by 2 and the bottom by negative 3. That's what I did. Okay, and again, this is my personal preference with numbers. You could multiply and eliminate your y's. It doesn't really matter as long as one variable is eliminated. We can see here that when we add our columns down, we end up getting a negative 15y equals 30, which then leaves us with y is negative 2, and then plugging that back in, we get x equals 1. Great job. See me with questions, and have a great night. Oh, don't forget to please make sure you've done the check your skills. You never know when I'm going to collect it.